Okay, good morning everyone. So last session, what we discussed in the last session, like what is Java, and next we done the discussion with the Java futures. Next we done the discussion with the Java history. Okay, like where they has released the how many versions they has released from starting onwards, and then Java program structure, and then we have done the discussion with the how Java programming language build, how Java programming language build a language. Okay, build. Next thing is how Java programming language build. Next we done the discussion with what is language, what is language, and then what is programming language. Okay, what is programming language, and then we done the discussion with Java program structure, Java program structure. Okay. Okay, then we done the discussion with the Java program execution flow. Java program execution flow. Java program execution flow. Okay. Next we done the discussion with. So these are the topics like JDK installation work. How to download JDK. How to download JDK software. JDK software and how to set up the paths. JDK software and how to set up the environment paths. How to set up the environment paths. So these are the last session I had done the discussion. Environment variables. Why we are setting the environment variables, meaning this is the permanent path. Okay, through the command prompt also we can give the paths, but those are temporary paths. If you want to give the paths as permanent, then every software you can give, I would say, if you want to make it as the permanent, then you can give the path in the system environment variables. System environment variables. Okay. So somebody is joining your course. Okay. So this we done in the last session. What is Java? Java features, Java history, how Java programming language build, what is language, what is programming language, Java program structure, and then Java program execution flow, and how to how to download JDK software, how to download JDK software, and then how to set up the environment variables. Okay, and where we done the discussion with what is the difference between JDK, comma JRE, comma JVM, JVM. Okay, this is also we done in the last session. JDK is the which will contain the tools which are helpful to develop the Java program. In case of JRE is the platform to run our Java programs. Okay, and then JVM is the virtual machine which is responsible for our Java programs execution. Also, this which is responsible for memory allocation and memory deallocation. Memory allocation and memory deallocation. So in the these are the regular questions. These are the regular questions, and we done with a discussion with compilation. Okay, compilation meaning we have the compiler tool. Okay, we have the compiler tool. What the tool will do? It will okay that will cover in the translators, compiler and execution. This is clear as of now. Today we'll discuss about the translators. Translator. What is the main purpose of translators is which are used to translate one format to another format, which are used to translate translate the data one format to another format, one format to another format, another format. Okay, so what are the translators we have in Java? So we have in Java we have three translators. Okay, in Java we have three translators. What are the three translators are basically, first one is compiler, and the second one is interpreter, and third one is interpreter, third one is assembler. Okay, these are the three translators we have in Java. Okay, what the compiler will do? Compiler is the translator. The main purpose of three tools, the main purpose is they will translate data one format to another format. Okay, the main purpose is the same, but in case of compiler, so which is used to translate the data one format to another format. Okay, compiler is the tool which is used to convert byte code into the binary language. Byte code into binary language. What does it mean byte code? Again, where we have the dot class files. Dot class files. We can say intermediate code. We can say intermediate code. Intermediate code. So this code it will convert to binary language. Binary language. We can say machine language. We can say machine language. Machine language, right? Okay. Next. What the interpreter will do? Interpreter it will convert it will convert it will convert byte class to it will convert dot class files, java files java files to mm, binary language. Byte code, and this is the intermediate code. This is clear. Intermediate code, okay, fine. So interpreter meaning it will convert, which is used to convert I would say byte code to binary language. Byte code to binary language. Binary language, or we can say byte code to binary language. Okay, so this is the machine language as well. This is the machine language as well. This is the machine language. Okay, fine. Next, assembler language. Assembler language is the tool which is converted to like byte code to assembler language. But this nowadays assembler language is nobody is using. So this is the deprecated one. This is the deprecated one. Nowadays nobody is using the assembling language. Nobody is using the assembling language. Okay. Nobody is using the assembling language. Nobody is using the assembling language, right? Which is used to convert assembler language. But nowadays nobody is using the assembler language. Okay, so after this we'll discuss about the JVM architecture. JVM architecture is the very important one, so we'll discuss about the JVM architecture. So JVM architecture, first the definition is JVM meaning Java Virtual Machine. Okay, Java Virtual Machine. What does it mean by virtual? What does it mean by virtual? Virtual meaning we cannot see with our eyes. That is the virtual one. That is the hidden part. So even me also, nobody cannot see. Even JDK people, whoever is introduced the like Java language, right? The James Gosling and this team, they are also not in JVM. Why? Because this is the internal one. Java virtual machine we cannot see with our eyes. This is the virtual machine. Okay. Then what will happen in the JVM architecture? So I will explain with MS Paint. I will take the MS Paint. Okay. So I will take new one. Okay, so yeah, we will write the source files, right? This is the source files. Okay, and then the source files we will convert dot class files with the help of compiler. Okay, compiler. So this after execution. So as of now, we discussed in the last session. Basically, we will write the source file. This is the source file. The source file meaning which is in the format of hello.java, hello.java. This is the source file. Okay, the source file we will convert it into bytecode with the help of compiler. Where we have the compiler is the tool. Compiler. Okay, compiler is the tool. What the compiler will do? It will convert source file into the bytecode. The command is javac and then hello.java. Hello.java. This is clear. And then the compiler it will generate the bytecode. The compiler it will generate immediately bytecode. Okay, bytecode has generated, and then which means all files are extension is the dot class files. This is clear. After this, we will give the command is javac. Javac. Whenever you are giving the command javac, then java demo, java demo, right? Whenever you are giving the command is java demo, then JVM came into the picture. So JVM is the hero of the Java. Okay. So whenever you are giving the command Java demo, then our hero will come. Okay. So our hero has the architecture that is, I will show you. This is the JVM architecture. Okay. Whenever you are giving the command, then the JVM come into the picture. The JVM architecture. So this is JVM architecture. What will happen generally? JVM architecture is made up of with multiple components. So what are the components will be there? We'll see one by one. So the first one is the class loader component. This is the class loader. Okay. After the class loader, we have the memory sections. Memory sections are like memory sections are like first one is the method area. Second one is the heap area, and third one is the PC register. Okay. Fourth one is the native stack. Fourth one is the native stack, and these are the different sections. Okay. I will write the names here. First one is the class loader. Class loader. I would say this one is the class loader. Class loader. Okay. And then this one is the method area. Method area. Next, this one is heap area. Heap area. Okay. Next one is this one is PC register. PC register. Okay. Next thing is Java stack. Java stack. Here we have the native stack. So these are the memory sections in the JVM, which is combination of memory. So this is the memory sections. It will be available like this. Memory sections. It will be available like this. Okay. So the each purpose of each component is what will happen in generally where we have the dot class files, right? whenever you are giving the command Java demo, then immediately JVM will come into the picture, and JVM internally it will have the component that is the class loader. What the class loader will do, the main purpose of class loader, it will load dot class files into the JVM. Okay, the main purpose of class loader is it will load dot class files into the JVM. Are you guys clear with my point? You are giving the command where you have the dot class files. So what the class loader will it will do, it will load dot class files into the JVM. Okay, after loading the dot class files into the JVM, immediately what the JVM will do, all the class related code will be stored in the memory. Okay, like for example, if you take the hello, the class name is like this. For example, if you take the class name is hello. Okay, hello is the class name, and if you write some set of statements, right? So all the class related code initially will be stored in the method area. Okay, the initial all the class related code will be stored in the initial method area. Okay, so going forward, we will create the object for every class. Object for every class. That object will be stored in the heap memory. Heap memory. So the main purpose of heap memory is the object will be stored in the heap area. Object will be stored in the heap area. Next thing is PC register. Okay, JVM main purpose is also lines, I would say, which is responsible for the program execution, right? So here what the PC register memory it will do, it will maintain the lines of information, which line is executing the current, which line has executed previously, which line should be executed the next. Okay, lines execution lines I would say lines information, which line is executing, which line has executed, and which line will be executed next. Lines information will be stored in the PC register. PC register lines information. Okay, lines information will be available in the PC register. Okay, now the class is declared with combining of variables and methods, right? Variables and methods, variables and methods. There if you take like a 10 methods or 20 methods, you can take number of methods. Okay, for example, if you take the 20 members, the methods execution information will be stored in the Java stack. Are you guys clear with my point? Methods execution information will be stored in the Java stack. Methods execution will be stored in the Java stack. So, which meaning which method is executing currently, which method has executed previously. Methods execution information are available in Java stack. Java stack, got it? And then fourth one is native stack. Native stack meaning in Java, like you can write some non-related Java programming also. For example, you can write the C and the C plus languages also you can write by using the JVM. By using the JVM. Why? Because so initially before the C and C plus language are the old languages. Basically, these are the starting languages, right? So at the time, like they has introduced, so this JVM architecture also made up of with this C language only. Are you guys clear with my point? This is the JVM architecture. Okay, this JVM architecture is also developed with the C language. So that's why in the JVM architecture, you can run C languages also. That's why they has provided some native languages. Native languages meaning not not related to Java. These are not related to Java. You can run C language also. You can run C language also. Okay. So that's why here some libraries they will provide. If you write any C programming or C languages, that code will be stored in the native stack. That code will be stored in the native stack. Okay. This is clear. As of now, is clear. I will explain one more time. Class loader is the component. What it will do, the main purpose of the class loader, it will load dot class files into the JVM. This is the JVM architecture, right? It will load, it will take and it will give to the memory sections. This is the entry point of the JVM architecture. What it will do, it will load dot class files into the JVM. Okay, after loading into the JVM, all the class code will be stored in the method area, and then if you create any objects for the class, that objects will be stored in the heap area. Okay, and every class contains set of statements, right? The lines execution information, which line is executing currently, which line is will be executed the next. So these lines execution information will be available in the PC register. And then next, Java stack meaning methods execution information. Like if the class contain n number of methods, right? If it is contain like 10 or 20 methods, which method is executing currently, which method will be executed the next. Methods execution information are available in the Java stack. This is clear. Next, native stack meaning which will contain non-related Java. Non-related Java. If you write any C non-related Java code also, you can run with the help of JVM, but the code will be stored in the native stack. The code will be stored in the native stack. This is clear. After this, uh, okay, here we have the dot class files only, but we categorize according to the memory. Like the JVM will, like if you create any object, it will assign the memory. So after this, what will happen? We have the execution engine, where we have the execution engine. Okay, you can assume this is the execution engine. What the execution engine will do generally? This is the execution engine. Okay, what it will do generally, where it will convert is all the places which is having all our dot class files only, right? So we have the execution engine. What the execution engine it will do? It will convert bytecode into machine language. For that purpose, we have the components are interpreter. So initially we have the interpreter only. I will tell the story. This is the execution engine. This one is the execution engine. Okay. This name is execution engine. This name is execution engine, right? Okay. And initially we have the component is the interpreter. Interpreter. Okay. Inter interpreter, right? So the interpreter, what it will do, it will compile bytecode into the machine language. But what is the disadvantage with the interpreter is it can convert line by line only. Okay, it will convert the line by line. Then if you can assume if the file is having the contain 1,000 lines, so what might be the, it will take obviously time taken, right? So that's why what the JDK people they do. So they has introduced JIT. Okay, they has introduced the JIT. JIT meaning just in time. So the main purpose of JIT is also to compile the dart class files into the binary language. To compile the dart class files into the binary language. Now, if you go with only interpreted approach, it will take lot of time to translate. Okay, so that's why if that is the performance is very slow, right? So that's why to increase in the performance, they has introduced the JIT component also. Now interpreter and JIT, the both main purpose is they will translate one format to another format. The first format is the, I would say, dot class files they can convert into the machine language. They can convert into the machine language. Are you guys clear with my point? This is the execution engine. Execution engine is consist of two components. One is the interpreter, second one is the jitter. One is the interpreter, second one is the jitter. Okay? And where we have the two subcomponents here. Those are like I will take some light color. Like if you can write a C language also by using JVM. So they also provided some C libraries. C libraries, in the C libraries which will contain some C related predefined classes and predefined programs and all. There can mention, I will mention here. This is the native libraries. Native libraries. Okay, native libraries. Next, so if you want to communicate the native libraries with the execution engine, there we have the mediator. The mediator is called native interface. Native interface. Okay, native interface is the mediator in between libraries and execution engine. Okay, generally here the flow, here it is. This is the native libraries and then native interface. These two will help when you write the C language. Okay, so until then we will not use this one. So remaining this thing is execution engine. In the execution engine, the main I would say, in the execution engine generally, what it will do, it will translate one format to another format. Which format? It will take as the input as the dot class files, and it will generate as the machine language, that is the binary language. It will generate 0 0 0 1, and after converting this one we'll be having again the finally we'll get the output here. It will go to the browser and the browser has the browser architecture, so there itself finally we'll get the output. So as of now this is the JVM architecture. Are you guys clear with my point? Initially we will write the source files. Okay, source files which can extension of .java, hello.java, like if you take the i.java. Okay, these are the source files. These source files we have the multiple tools. Compiler is also tool. What it will do, whenever you are giving the javac command, so compiler will come into the picture and it will generate the byte code. Byte code meaning this is the intermediate code. This code cannot understand by the human, cannot understand by the machine. Okay, next after generating the bytecode, we will give the command, that is the Java demo. Whenever you are giving the command, then JVM come into the picture. Okay, and then this is the JVM architecture. JVM architecture, which is the combination of multiple components. First component is the class loader. Class loader is the entry point of the JVM architecture. What it will do? It will load dot class files into the JVM. It will load dot class files into the JVM. Okay, once it will load the dot class files into the JVM, all class related code will be stored in the method area. Okay, we will create the objects. Object will be stored in the heap memory, and lines execution information will be stored in the PC register, and methods execution information will be stored in the net Java stack. Here, methods execution information. Okay, methods execution information will be stored in the Java stack, and non-related Java information will be stored in the native stack. And where we have the execution engine, what it will do, it will convert Java dot class files, meaning bytecode to binary language, bytecode to binary language. Okay, bytecode to binary language. So this is all about JVM architecture. Okay, I will show you through the PDF. You guys can you please observe that one as well. Okay, so these are the topics we done in the last session. Translator. So if you see, can you please all of you read this statement? Translators are used to convert one format to another format. Next, we have three types of translators. What are the three? Interpreter, compiler, assembler. Okay, what is the first one? Interpreter will convert program line by line. If it will convert line by line, that what might be the issue? Performance is slow. Okay, what is the second line? Uh, Compiler will convert all lines of program at a time. Performance is fast. Okay. And the third one is assembler is used to convert the assembler language into the machine language. Assembler language into the machine language. But nowadays nobody is using the assembler. Okay. We are using the only two. One is the interpreter. Second one is the compiler. Okay. Third one is the JVM architecture. In the JVM architecture, what is the first line? JVM stands for Java Virtual Machine. Next, we cannot see with our eyes. That is the virtual. Next, JVM will be part of JRE software. Next, JVM is responsible for program executions. Java program executing the Java programs. Next, ఏం తెలియదట తెలియదా ఏమి Okay, this is clear. Meaning it will allocate the memory and it will deallocate the memory. Okay, what does it mean by allocation? What does it mean by deallocation? Will we will get the clarity coming days. Okay, as of now, the memory. This is the one responsibility of the JVM. It will allocate the memory and it will deallocate the memory. Next line. JVM will convert byte code into the visual understandable language. Okay, this is the JVM architecture, like source file, Java C, and then compiler will start. What the main purpose of compiler is, it will check the syntax mistakes. Syntax mistakes meaning it will look for the semicolon, and you are following the proper guidelines or not. It will initially it will check. If you are following the everything is okay, then it will generate the byte code. It will generate the bytecode is called dot class files, and then this is the, I would say, the components: class loader, method area, heap area, Java stack, PC register, and native stack. Okay, and this is the execution engine. In the execution engine, where we have the interpreter, JIT, and output, we will get the final output, right? Native stack, native libraries. Okay, can you please read all these points one by one? What is the class loader? What it will do? It will load dart class files into JVM. Okay, fine. Next, method area. What it will do? Class code will be stored here. Meaning, whatever the code we have written in the class, all the code will be stored in the method area. Okay. Next, what does heap area will do? Object will be stored in the heap area. Okay. Next, Java stack. What it will do? Methods execution information will be stored in the Java stack. Methods execution, like which method is executing currently. Okay, methods execution information will be available in the Java stack. Next, PC register. It will maintain lines information. It will maintain next line information to execute. Okay, next native stack. Native stack. It will maintain non-Java code execution information. Okay, this is clear. Next, native interface. It will load native libraries into the JVM. This will act as a mediator in between the libraries and execution engine. Next, native libraries. Non-Java libraries which are required for the native code execution. Next, execution engine. It is responsible to execute the program and provide the output. It will use interpreter and JIT for the execution. JIT for the execution. This is clear. This is clear. In the chapter number 1, we had completed this the syllabus. So introduction, we have done the discussion, and then Java features completed, Java installation completed, Java program execution flow we completed, Java programming elements we completed, Java program development we completed, compilation we completed, execution is completed, translators is completed, and then JVM architecture is completed. This is the very important part. This is the very important part. So especially JVM architecture is the very important. If you're not aware of the JVM architecture, you cannot understand anything in the Java. Why? Because so in the real-time scenarios, methods deals with the objects only. Okay, methods deals with the object only. If you don't know like what does it mean by heap memory, and then how will you how will you do the programs? Normally you can manage the programs, but But if you know the internal process, then you will have the good confidence. For example, I will tell here. For example, if water is flowing from this place to this place, for example, you can assume like this. This is the water, and then some slant will be there. If the water is flowing from here to here, so anybody can swim from top to bottom, meaning the direction of water is also same. So anybody can able to swim this direction. But meaning, but whoever will swim opposite the water, then what does it mean? The person knows about how to swim compared to this person's. Okay, in the programmatical also we can manage. But if you know the internal process, what is the process happens internally, then you will get the confidence. Okay. So in the Java, like in our sessions, we will tell not only doing the programs, we will tell how to analyze the code and how to write the programs. If anyone can tell the requirement, that requirement you can solve in multiple ways. That requirement you can solve in the multiple ways. So we will give the how to analyze. If the client, if anybody will I would say tell the requirement how to analyze and which is the best solution for that, for that one, we will give the analyze, how to analyze the code like that. Okay, if you want to analyze the code, we need to know internal process, what is the process happening internally. Okay, everything is important. JVM architecture, please practice multiple times. So in the coming days, in the next chapter, we will discuss three topics: variables, data types, identifiers, reservoirs, Java coding standards, and then Java commands, read the data from the keyboard. Okay. Some rules will be there while writing the naming conventions for the class, variables, constructors. So those we will discuss in the coming days. Okay, this is all about the JVM architecture. What you guys will do, you guys practice the JVM architecture. So tomorrow I will ask the KT about the JVM architecture. Everybody will give the notes or code, and then you can explain each component. Okay, this is today.